Good afternoon, good evening, good morning, everyone in the world. Welcome to our seminar, New Development of GOSAT Series, Japanese GHG Center, and Use of Satellite Data for Business. Thank you for joining today. This seminar is organized by Ministry of the Environment Japan, National Institute for Environmental Studies, Japan Agency for Marine Earth Science and Technology. I'm Tazusaiki, Senior Researcher of NIS. The seminar provides you the information on monitoring greenhouse gases by satellite remote sensing and application of satellite data to business toward net zero society. So this is the agenda of today. So first we welcome Mr. Yutaka Matsuzawa, Vice Minister for Global Environmental Affairs, Ministry of Environment, Japan.
Thank you, Saiki-san. Thank you all for joining us today in this scientific event on greenhouse gases observing satellite, GOSAT, contribution to climate science, climate action, and policy. We are very honored of having Madam Edith Silman, Minister of Environment in Israel. Thank you for coming here. This event is organized by National Institute for Environment Study and the Japan Agency for Marine Earth Science and Technology and Ministry of Environment Japan. The purpose of this seminar is promote climate actions toward net zero, of course, by sharing the latest scientific outcome and cutting-edge initiatives in the business sector using GOSAT data. In addition, we'll explain third-generation satellite GOSAT-GW as well. The seminar has two parts. In the first part, we will have presentations from experts, followed by panel discussion in the second part. Regarding GOSAT-GW, the third-generation satellite, it is now in the final stage of adjustment before its launch. It will be able to acquire 100 to 1,000 times more data than GOSAT 1 and 2, and will be able to make precise observation at maximum 1 kilometer resolution. GOSAT contribute to climate science, climate policy, and actions by providing global size data set since 2009. Finally, I appreciate huge contributions made by GOSAT science communities and long-term understanding of Japan's taxpayers. Thank you very much.
Thank you very much, Mr. Matsuzawa, for kind remarks. So first speaker is Dr. Hiroshi Tanimoto, Deputy Director of Earth Science Division, NIS.
Thank you. It is really great pleasure for us to be here. I'm really surprised to see all of you coming here. You know, not many people that don't have seats. It's really exciting. I mean, for us. Thank you very much for coming. We are here today to share with you our exciting news that's coming this year and also continuing next year. Two exciting news. The first one, as Mr. Matsuzawa said, GOSAT-GW satellite mission, in particular greenhouse gas observation mission. Second one is the planning of the Japan Greenhouse Gas Center. We are really excited. It's a lot of work, but we are really excited. And I hope after listening to my talk, you get excited as well. So let me start by saying a few words on greenhouse gas measurements from space. GOSAT which was launched back in 2009, is actually the world's first greenhouse gas observation satellite. We believe this is really, really successful because we got international community efforts from scientists, including US, Europe, and also other countries across the world. So that's really international efforts making it success. This is funded by Ministry of Environment and also MEX, which stands for Ministry of Education and Science and Technology, and also operated by NICE and JAXA jointly. So you see here, this is really national, multi-ministry, multi-agencies effort together with multi-institutes efforts. JAXA is responsible for the launch, rocket, of course. This is what they only can do, level 0, level 1 products, and also NICE is responsible for the level 2 product and higher products, level 3, 4, 5, whatever, such as fluxes. So we are really interested in concentrations and the fluxes of greenhouse gases. GOSAT-2 was launched back in 2018, so that's already, say, 6 years ago, and GOSAT-GW, which is the third one, is coming soon. Why I can say it's really coming soon? Because rocket is now ready, for sure, and sensor, which is called Tanso-3 sensor, is in testing on the ground. So everything's running well, we hope, and it's going to be launched by the end of Japan's fiscal year, 2024. Japan's fiscal year is not from January to December, it's from April to March, so we still have like 3 or 4 months. So it's really coming soon, and we are really excited. How GOSAT-GW is going to make measurements of greenhouse gases from space. This is how it's going to be, like. And GOSAT-GW is going to make measurements of CO2, methane, and nitrogen oxides over the globe within 3 days. So full coverage within 3 days is really, really new thing. From satellite observations from space. We have 3 mission requirements, and first one is to monitor 4 atmosphere global mean concentrations of CO2 and methane. Like you can see here, famous plots of CO2 concentrations. It's increased over the last decades from Hawaii and South Pole. And you see here some plots from GOSAT satellites. You can't see difference actually, but this is really making sure that GOSAT data is really, really high quality. Second challenge is to verify country-level anthropogenic emissions of CO2 and methane, which I'm going to touch later a little bit. And third one is really new challenge to detect greenhouse gas emissions, in particular CO2 emissions, from large emission sources such as like Tokyo or maybe Baku, and also power plants and maybe permafrost. So big emitters. So what's unique with GOSAT-GW greenhouse gas measurements is maybe like this. It has the capability to make focus mode observations over targeted cities like Tokyo, Baku, as I said, and also targeted power plants or whatever industrial emissions. You can see the movie here a little bit. Nominally, operation is like a wide swath, 900-kilometer wide swath, which is having also 10 by 10 kilometer footprint, spatial resolutions. That's also good enough. But also we can optionally have focus mode observations targeting specific cities or emission sources with spatial resolution of 1 by 1 kilometer resolution, which is really, really high. It's the highest in the world, if we can make it. So we can make combination of 2 observation modes for the better contribution to the climate change mitigations. Right, this is the first news from us, and I believe you get a little bit excited. But I'm going to make you a little bit more excited with the second news by telling you the planning of the Japan Greenhouse Gas Center. If you have a smartphone here, you can have a quick QR code. Just try. I'm going to stop here a little bit. That website is already up. It's just a test phase, beta phase, so don't complain too much. I'm happy to hear complaints, but don't complain too much. We're really shocked. But this is entitled Japan's Greenhouse Gas Information System, which is really important for us to do. The US has started a US Greenhouse Gas Center last year in COP Dubai. So we are following their activities 1 year later. We had conversations, I would say, with the US Greenhouse Gas Center people like NASA, NOAA, NIST and US EPA. So that's really making contribution to make it happen. So we'd like to deliver make it Japan Greenhouse Center as one-stop information hub or platform for the scientists, of course, for the policymakers, of course, and also for the business leaders and whatever applications, applicants. We would also hoping to deliver a unified, strong message on urgent needs of climate change mitigations. And of course, international efforts, contributions, including global stocktake, WMO's G3W, and UNEP IMEO's methane initiative is also something we are eager to contribute. And of course, business applications, and I would like to discuss together with you here today. Why you can make it so quickly? Because we already have a lot of active research elements, which could be or should be the basis of the Greenhouse Gas Center of Japan. Here, you see the ground-based monitoring, like in Hokkaido, or Okinawa, or even Mount Fuji. Satellite measurements goes at 1, 2, 3, and cargo ship measurements and aircraft measurements in collaboration with the private sectors, like cargo ship companies, and also Japan Airlines. So that's really unique components for us as a Japan Greenhouse Center, and also Japanese research capabilities. Of course, we have inventory office, and the model is getting higher and higher resolutions. And we have really more than few excellent modelers in Japan. And probably Patla is making another note, and also Igor Kanaya Jamstek is making a note after me. So this is, I apologize, this is really needs focus, but you can see, there are so much more activities in Japan. So one thing already doing is that bulletin of multi-scale emission of greenhouse gas budget, which already we submitted to global stocktake processes last year. So we're gonna develop further with the Japan Greenhouse Center. I would like to share with you 3 examples of how we can deliver within the framework of Japan Greenhouse Center. The first one is like this. This is high resolution simulations of a global carbon cycle, like CO2 emissions and sinks uptakes, based on inverse analysis of the sources and sinks of CO2 on the global scale. This is new, really high resolution, 1 by 1 degrees resolutions, estimates reveal detailed features of the emissions in North America here maybe, and also Western Siberia like this. So you're going to advance this research further to contribute to the operational monitoring of CO2 sources and sinks on the globe, maybe contributing to the WMO's GCW. Second one is to verify country-level emissions of CO2. I would say, as a scientist, this is really, really challenging work, but we try. So here you see the enhancement of CO2 from GOSAT observations, and also model enhancement, from calculated from the model with the existing emission inventory. So we can compare this observation and model 1 by 1, and we can say a little bit like emission inventory can be underestimated or can be overestimated for individual countries or areas of big emission sources. So we're going to further develop this research to better contribute to the country level nationally determined contributions. Finally, maybe this is a little bit easier for you to understand because this is a time series of methane emissions, anthropogenic emissions as a time series from 2009 to 2020. Orange dots are UNFCCC emission inventory, national emission numbers. And blue dots and also range are top-down estimates from the model. So you see here, sometimes good agreement, sometimes not good agreement, some years good agreement, some years not good agreement. But again, this is really challenging. And we will strive to update the verification evaluation with these country-level CO2 and methane emissions to better contribute to the policy-making processes with new research for more years maybe, and for more countries and areas. And I think Pravil is going to touch a little bit with a different perspective. Okay, so to wrap up with the Japan Greenhouse Center coming soon, we will advance integrated assessments of greenhouse gas emissions and fluxes and spread information as one voice to help support climate change mitigation policies. This is 3 multi-agencies, multi-ministries, and multi-institutes efforts for the All Japan One Team national initiative to better serve the global community, our society. So thank you very much for your attention, and I'll be happy to discuss further in the panel discussion. Thank you.
Thank you, Hiroshi, for introducing Japanese activities for GHG gas consequences. So next speaker is Dr. Yugo Kanaya, Director of the Earth Surface System Research Center, JAMSTEC.
Thank you very much. So for more local emission context, I'm going to talk. And satellite images of column average CO2 concentrations, or XCO2, are so powerful for identifying plumes, like here, as shown in the right-hand side. From Tokyo, for example, the various plumes are emitted from the large point sources. But caution is needed when converting them into the emission fluxes. Yeah, like this, depending on the wind, day by day, this kind of observation would be possible. But we address this question by combining two research-grade model systems. One is 1 kilometer mesh regional scale model of GHG and CHEM. That is backed up by qualified global scale Miroku 4 ACTM model. And of course, GOSAT-GW is just before launch. This is just an image pseudo observation created by this model system. But I'm going to show how this system is effective for the emission analysis. And here the focus is on the Kashima industrial zone that is east of Japan, east of Tokyo, sorry, and medium-sized point sources emitting 16.6 megaton CO2 per year. And as shown here in the plume, we may expect the enhancement of the so-called XCO2 by 2 ppm, shown by the color. But this is quite often superimposed by the larger plumes coming from the continent, and particularly for the 7-kilometer altitude, higher altitude. But our global scale model identifies such transport event quite well by comparison of the vertical profiles with the contrary aircraft-based observation as shown here. So this helps to select cases for the analysis. And for the selected cases, we apply the so-called divergence method to estimate the CO2 emission fluxes. And this is just to put a wall surrounding the emission point, and we estimate how much CO2 is coming out through the walls by the wind. And this is just quite similar to, just imagine the hot spring in Japan, and we just similar to the estimating the underground water supply to the hot spring by measuring the spring water spills. And we applied this method and to the pseudo observation and verify that the true value is obtained. And then we further added the expected sensor noise that is very conventionally assumed as 1.8 ppm. And the flux estimation was repeated to obtain the statistics and with a random noise. And here's the result, and we may expect a 32% of the uncertainty when analyzing the 60.6 megaton CO2 per year. So here we first combine the performance of the satellite to the CO2 emission analysis uncertainty. So the GOSAT-GW Tanso 3 will measure NO2 together with CO2. And this will help on the wind characterization analysis. Even with the noise, the NO2 measurement will have the higher signal-to-noise ratio. And then the plume identification is much better than the CO2 case. This helps reduce the errors arising from the wind uncertainty. And second, this will help new emission source identification. So here is an example from India, and in the west part, just a known emission sources from the bottom-up emission inventory will show that just two hot spots. But in reality, this is actually from the really existing TROPOMI satellite from the ESA. But in this case, we have more emission sources like this. So by this, with goals at GW as well, we would like to identify the missing sources in the bottom-up emission inventory. And we first estimate the NOx emission amount to be able to explain the satellite observed quantities. And then by using the external information of NOx to CO2 ratio emission factor, we can further estimate the CO2 flux. So in summary, we will provide flux estimates and hope predict changes as a good indication of the mitigation actions. And there are challenges, sensor performance, interference from vegetation uptake, and so on. But we would like to hope to work on that. So some related but unmentioned information is that the global model, the Miroku for ACTM, was separately used with methane isotope information recently, suggesting that as much as 75% of recent day global methane emission is coming from waste, landfill, agricultural wetland. So this may give further context for the further study. Thank you very much.
Thank you, Hugo, for introducing a state-of-the-art modeling system for GOSAT GW analysis. So, our next speaker, we expected to NASA members, but unfortunately, they won't come for some reason.
Yes, so just a little bit. We originally have a plan to have a NASA, a USGH center representing. I'm sorry, I was drinking water. Apologies. They are really happy to come here to talk about USGH center, but we had last minute cancellation, unfortunately. But we are really, I would like to say, we are really having great close conversations between Japan and the US, and of course, we are open to have similar conversations with other, countries and research institutions, ministries, to make this international initiative, broader initiative. So I would stop here, but just wanted to say this is a really great thing for us. They're helping us a lot. So skipping. So they are big brother, and we are like, I don't know, younger brother, maybe, something like that. Okay, so next.
So we move on to the next speaker. Next is Mr. Masahiro Naka, Deputy Director for Energy Diplomacy and LNG Policy, Ministry of Economy, Trade and Industry, Japan.
Thank you very much for the introduction. I'm Masahiro Naka, in charge of LNG policy of Ministry of Economy, Trade and Industry, Japan. I will explain today how Japan intends to work together with other stakeholders and international organizations to reduce methane emissions across gas value chain by policy measures. Japan itself is a country with low methane emission from the energy sector, as already Minister of Environment explained. However, Japan, as a major importer of LNG, play an active role in managing methane emission in the global LNG value chain. Last year, Japan and Korea announced a coalition for LNG emission abatement toward net zero, or the Korean initiative. The Korean initiative aims to reduce methane emissions from the LNG value chain. First, could you please look at the figure? LNG Korean is a win-win partnership between LNG buyers and producers. LNG buyers and LNG producers, LNG buyers send LNG producers the questionnaires on methane intensity and emission reduction measures at project level. LNG producers respond by providing data on reduction activities. This is the world first activity to disclose the methane emission reduction data and their measures by project basis. JOGMEC, Japanese government body, coordinates the entire process, manages the database, and disclose the data and the best practices in the dedicated website, and which is announced as a Korean annual report last month. Could you please download that JOGMEC from the JOGMEC site. The Korean initiative is voluntary basis, but very strong because it is a peer pressure mechanism for disclosure led by LNG buyers. Therefore, the buyers are willing to join as they will have access to cleaner LNG. The producers also have merit to join because they can showcase their emission reduction efforts and appeal the low emission as their strengths. Secondly, Korea has high coverage and expected to grow further. It covers the world 25% of energy buyers. The number has expanded from original 2 companies, JERA and KOGAS, to 24 energy buyers today in Japan and Korea, which is covers almost all the Japan LNG imports and almost 80% of Korean import of LNG. On supplier side, the Korean has even larger coverage of 40% of LNG producers. The major gas producer companies worldwide acknowledge the Korean initiative. As I explained earlier, this initiative is based on the producers buyers dialogue. That's why the acknowledgement from energy companies is very important to activate this initiative as a very effective measures. Lastly, as the LNG value chain is global, international collaboration is must. The Korean initiative is working in hand with 6 international organizations, including UNEP, IMO, and IEA, and other energy-related entities. With IMO, potential area for further cooperation is data using GOSAT GW, which is explained by the other presenter. IMO already provided good database for the Korean annual reports. Furthermore, also rich data from Japan's new GOSAT GW satellite to be launched in 2025 will add value to IMO database as well. Japan, as a pioneer LNG user, will be the top runner in reducing methane emissions from the LNG value chain by bringing together producers and importers through the Korean initiative. Thank you very much.
Thank you, Masahiro-san, for important activity to reducing LNG methane. So next speaker is Kei Yano, co-founder, CEO, Contribute Labs.
Hi, everyone. Thank you very much for having me today. My name is Kei Yano, co-founder, CEO of Carbon Tribe Labs, an Estonian company founded by Japanese founders. And our team is distributed around the world. Our team is in Netherlands, Germany, and also in Singapore and the US and Japan. And what we are trying to do is reinventing the carbon credit as a carbon removal digital assets, which is actually powered by the Web3 technologies. And we actually have partnered with a lot of NGOs and corporations, and mainly conducting the POC in Southeast Asia. And there is a common problem. The low profitability of the carbon credit actually blocks the market potential. And for example, like carbon credit, voluntary carbon credit generated by Vera, it in the mangrove, for example, carbon credit, it actually, when considering of the profitability of the project, it needs to have at least like 10,000 hectares of the land, which is an enormous amount of land. And it is almost impossible for many companies or NGOs to make a carbon credit with a scheme. So actually, we have created our own standard, which is a Web3 based. And we are the first provider of the Web3 based GHG removal standards. And we have currently developed 3 different methodologies already. One is for CO2 for mangroves and forests, ARRs. And the second one is a methane and also nitrous oxide, which is a 300 times larger impact, which brings a larger impact to the greenhouse gases. And the benefit of the digital standard is actually, it's the first lower cost and transparency. especially the project data and trading logs, everything we can make it transparent via digital schemes. And we can also avoid the greenwashing through that scheme. So when comparing to the traditional voluntary carbon credit, we are transforming from expensive black box to credit mining machine by generating credit by our technologies. So we also create the single source of truth of the area by our monitoring system, our DMRV. We make everything tangible from space and also store the data captured from that computer vision and make it tamper-proof way, store the data tamper-proof way and transparent to see who sold and bought in the market. So we have also a free digital GHG removal certificate generation platform. So we have a proprietary AI algorithm created by us, and we are backed by top investors and partners already. We have just started 1 year ago, but supported by a TEPCO group company in Singapore and also Texas Sustainability Paris, and also lots of companies including Itochu and Google. And our strength is actually the in-house AI algorithm for science-based GHG sequestration calculation methodologies. So this system is actually adaptable for any data source, not just about the satellite imagery, but also many different use cases. For example, when we can let our machine to run the GOSAT data, and we can also create the methane removal digital asset as well. And also, this methodology is very flexible for the data entry. We can also adapt to the, for example, like refrigerant replacement or like heat pump replacement as well. And also other than data source other than the methane, but also for nitrous oxide and many GHG gases. So our team is comprised of ex-Google BizDev and ex-Bosch AI developers, but also with a resource trader, NFT tokenomics, and carbon credit specialists and climate scientists. So we are really looking forward to collaborate with GOSAT data, and also looking forward to collaborate other corporations, NGOs, collaboration opportunities. Thank you very much.
Thank you very much, Kay, for introducing us a very new technology for GHG sequestration.
Hi, thank you very much. This valuable opportunity for us. I'm Takumi Hashizume from MUFG Bank. So I'd like to start by discussing MUFG transition white paper. This is a kind of the carbon neutrality purpose discussion paper. Through global discussion using this paper with global industry leaders, we found that different stakeholders have different concerns and speak in different languages. I'm not talking about different native language things, but rather to the different background of each stakeholders. These are the very important part of the transition paper 2024, that in advancing this discussion, it is essential to objectively measure the direct impact of decarbonization and to identify new values. So we have been focused on the potential of satellite data, which deliver the solution across various sectors. So let me introduce some of our initiatives. First, NYK Line and MUFG have been working on the joint proof of the concept to monitor the correlation between ammonia substitution ratio and GHG emission. When the ship fuel is replaced with ammonia to reduce GHG emission, this is a new technology. Next, this is a global collaboration using GoSat technology. I'd like to pass to Stefan, CEO of the GHG Sat, our valued partner. So Stefan, please.
Good afternoon. My name is Stefan Germain. I'm the CEO of GHGSat. So we at GHGSat have been for years working on combining satellite systems, our own fleet of satellites. We have 12 in orbit now that provide the highest resolution services in the world for monitoring methane from space. And we combine that with national satellites such as the European Space Agency's Sentinel-5P, and now, of course, GoSat. And we're very much looking forward to partnering on collaboration with GoSat and GoSat GW, and what we can do with GHGSat to tip and cue to help reduce the cost of monitoring by using the power of GoSat to help point the GHGSat satellites to the most precise area possible to then deliver services for insurance, for banking, and for other services. It is very important then to use those kind of collaborations to support frameworks such as the UN's OGMP 2.0 that the latest recommendations allow for the use of satellites, large scale and small scale, to support the measurement to the standards that allow reductions of emissions worldwide. Back to you.
Thank you, Stefan. So next, JAXA and the MUFG are collaborating to measure the amount of CO2 observed by the forest. These are the kind of the direct observation method may reduce the potential risk, such kind of the greenwashing. Well, we will use the GoSat related technology, step 2 in this project. So this is a kind of a summary that satellite data has the potential to become a strong support tool to create common languages. It is essential to, it is important to create the transparency for everyone in advancing the sustainable finance. And we want to create the fair market using these kind of data. Then this stimulate the finance and the investment for corporation activities. So sustainability is ultimate accountability for us. And we, as a finance institution, have a huge responsibility on that. We believe that satellite data has a potential to be a compass for the leaders who tackle climate action. We must be a supporter, a partner for those leaders. It may be you for the next generation in this planet. Thank you very much.
Thank you, Takumi and Stefan, for introducing us a new possibility of combining finance and satellite data. So now we move on to the panel discussion session. So Hiroshi takes the floor.
Right, thank you, Tazu. Okay, so you're really on track, and we're going to make a panel discussion to discuss about what's the expectation for GoSat GW in particular, for the decarbonizing, society we should achieve soon. So if you find your name, just come up. Pravir Patra, I can't see it. Rohan Ruhi here, Stefan Germain, and come on. Okay, good. So, and actually they have some few slides to say few words. So we could start from Pravir, then like this. And then hopefully, if time remains, we could have questions from the floor. to make some discussions on that. Okay, probably you're going to start.
Okay, I'll try my best. So, okay, we have about the local scale things and point observations. So, but we are doing research on greenhouse gases. So I will tell you about the GOSAT for country reporting and UNFCCC GST kind of research. Bulletin we every year for last 3 years, and we submit the bulletin to UNFCCC for GST 1, and that was already discussed. But if you have heard on the Monday, Earth Information Day, people have been asking the greenhouse gas concentration keep rising in that atmosphere. CO2 is rising, methane is rising, N2 is rising, and also in accelerated pace. So the question from the audience was, from where the emissions are coming? This is one of the tasks we take up as a scientist and try to provide information in the subcontinental scale or big country scale. We do not talk about any local scale things. Our models are global. We need to have a sum of the global emissions from anthropogenic activities, from natural activities, El Nino, La Niñas, everything, to account for all the concentrations, each molecule in the atmosphere, which is building up year by year. That is our task. And doing that, we have the left side, you can see different regions have a different emissions, the flux, but it is from the observation data dots. So GW will fill up anything, many things, where you see in the right side. So you can plot the latitude versus on the y-axis in the middle panel, so that it is filled up, but a lot of gaps still remains. So GOSAT GW will supposed to fill up these gaps and improve our understanding in the modeling systems, which you can actually do the much better job in the future and attribute anthropogenic and natural fluxes for the community. And this is our kind of a business to provide social information for a scientifically valid way and based on the observations, and to make policy for the UNFCCC, IPCC, and those kind of tasks. This is our business for the society. Thank you very much.
Okay. Thank you very much. Thank you very much, and good afternoon. So I'm Laurence Will. I'm the director of the Copernicus Atmosphere Monitoring Services, which are services implemented by the European Union for monitoring Earth. And CAMPS is an integrated framework which integrates observation, in situ observations, but also Earth observations with modeling systems to be able to provide some information about atmospheric composition. I mean, air pollutant concentrations and greenhouse gases concentration. So our main purpose, and this is the implementation, the operational implementation of global and regional system focused on Europe that deliver every day forecast analysis, I mean daily analysis, which are the best estimate of the concentration of the airborne concentrations that we could elaborate, and historical reanalysis data sets to be able to provide an information about what happened for 20, 30 years, and to elaborate some trends, based on both observations and modeling, to be able, regarding the trends, to maybe assess the efficiency of mitigation strategies and maybe adaptation strategies. So this is the main purpose of the CAMPS services. Another aspect I would like to highlight is the delivery, the provision of information about emissions. Emission inventories that are, of course, essential to produce modeling and as output, input for, of models, but also thanks to inversion system, comparing what is measured from Earth, what is measured from in situ network, comparing measurements with modeling results, you can assess some gaps. Regarding the gaps, the location of new sources, but maybe also the quantification of those sources that maybe could not be correct. And this is a way we will be able to elaborate some verification systems. And within CAMPS, this is one of our main objectives today, to be able to elaborate
operational verification system. This is a service which is called CO2 MVS, CO2 monitoring and verification support to support implementation of policy. It's called CO2, but we deal also with methane, and methane will be a big issue, and we are working hard on that, and maybe N2O. And what's about GOSAT? You see, GOSAT is one of the satellite, is a source of satellite information that we assimilate in our systems. I have to say it's working very well, and it's working in combination with all the other satellites. And we are keen on knowing what knowing what GOSAT GW will bring with high resolution data combined with NO2 data. This is, as you say, this is really essential for the improvement of our service and also the improvement of what we can deliver to society, I hope. So.
Thank you.
All right, as I mentioned earlier, GHGSat operates 12 satellites in orbit today that are specifically designed to monitor facility level emissions. So they offer a resolution on the ground of 25 meters so that we can pinpoint the source of an emission. And we have the lowest detection threshold from satellites available in the world today for detecting small sources of emissions of methane. So we can detect emissions as small as 100 kilograms an hour of methane. And we see that all over the world, already in some parts of the world on a near daily basis. And we are already ordering 9 more satellites. So we're going to nearly double our constellation in the next 18 months to, again, provide that much more capacity. In addition to all that methane monitoring capacity, we also have CO2 measurement capabilities. So what you see on the slide here is examples of some of the markets that we serve. In this slide, it's all about the industrial markets that we support and focusing primarily on oil and gas and waste management is the 2 biggest ones, where we have customers all over the world that ask us to track their emissions so they can understand them better, control them, and reduce them. And on the next slide, we talk more about government and how we work with government and financial institutions, as we just described with MUFG, how we work to help understand the emissions that affect their portfolios. And on the final slide, all of that at the end of the day translates to what everybody here at COP29 is talking about, and that's action. So in 2023 alone, working with our customers and our partners, we enabled mitigation of over 6 million tons of carbon dioxide equivalent. That's like taking 1.5 million cars off the road for 1 year. Over the history of our satellite system, we've helped mitigate over 15 million tons of carbon dioxide equivalent. And for us, that is just the beginning. So we work with our partners, including MUFG, and working with satellites like GOSAT GW and the existing GOSATs to help tip and cue our satellites to be more efficient, to reduce our costs of offering services to customers, as I just described.
So hi, my name is Roland Coopers from the United Nations Environment Program. So our observatory, IMEO, exists to provide open, reliable, and actionable data to the individuals who have the agency to reduce methane emissions. And we really mean the individuals, right? Our activities want to connect with the people who can do the mitigation. But in this process, satellites play an important role because of their potential to collect fast and accurate data, but unfortunately only on the largest sources of emissions. So it's part of the solution, but it's certainly not the entire solution. So our tool for this is called the Methane Alert and Response System, or MARS. And what it does is it combines the recent observations from a whole range of satellites to detect, but then to notify both the governments and, when we know the operator, on UN letterhead about the integration, about the integrated data. We also use satellite data for some of our other programs, for example, for science studies or for the oil and gas methane partnership, as you've described, baseline studies and others. So today we use more than a dozen satellites with various space missions to integrate this data. And we plan to continue to expand that as new missions come up. And so based on its design, what we really hope to integrate is GOSAT GW, and we're very excited about its capabilities. In particular, we hope to obtain more accurate measurements than those currently obtained with Tropomi, thanks to its band at 1.6 micrometers and the methane proxy data product. This will give us better coverage in areas that currently are difficult to observe. Everybody loves to show Hassi Mesud, but that's the easiest place to measure. And because, we think in that band, there will be less problems with cloud filtering and observational biases in wetter latitudes and in higher latitudes, where currently we fall short. It also has the potential to reduce artifacts and false positives related to the albedo and aerosols, and so therefore improve the sensitivity and optimizing of methane emissions compared to the data that we currently have. So IMEO, and we don't do this alone, right? We collaborate with the ESRON, the Netherlands Institute for Space Research, with NIAS in Japan, with JAXA, the Ministry of the Environment in Japan, and we'll jointly explore how we can integrate the GOSAT GW data. And we have extensive machine learning tools that we've built in order to integrate these multiple satellite data streams. And it is really in this diversity of satellites that we see the ability to cross-validate and improve data quality. And ultimately, our efforts, both in working with companies and with satellites providers, is getting the data quality of methane emissions up, which frankly is not very good today, and it needs to become better. So in conclusion, I'd like to stress that the most appreciated feature of satellite data in IMEO, particularly for Mars, is the rapid availability. And rapid action on methane data is critical because our goal is mitigation, right? Is getting to the operators. And we currently have relationships with 140 oil and gas companies with signed MOUs. And so we have open connections to them. And particularly, we would really appreciate the possibility of analyzing GOSAT GW's detections as soon as possible after the acquisition. The shorter the delay, the better. And that would allow us to engage with both governments and the companies to try to get the mitigation access. So this rapid access to data is something we'd love to discuss with you and get better. Thank you so much.
Hi, everyone. Daniel Kashmir. I will not talk again specifically about Momentic. We already heard it, but I will say a few words about GOSAT GW and about how we see the process of methane mitigations. Okay, we are welcoming GOSAT GW. We think that it's a huge contribution to the process of mitigation. We see the high sensitivity of your satellites is crucial inside the process. We think that this is how we see it is it's like the first stage in the process. We already used a little bit in GOSAT 2. We did it with Sentinel-5. Those satellites, especially GOSAT GW, with its high sensitivity, is showing us and others a large area. It can tell us data about emissions in broad areas. And right after, companies like Momentic and with technologies such as us and others can come to the area and provide pinpoint monitoring and can tell the specific customer, specific company, specific government, where's the problem? Where's the problem inside a long pipeline channel, inside any kind of industrial facility that involving CH4? So for us, it's crucial. It's helping a lot. And we think that such a project can help us all with awareness, okay, to promote awareness worldwide and in specific places, and eventually maybe to contribute or to create a new regulation that's supporting all the mitigation process. So this is our perspective, and thanks for that. Thank you.
Hello, everybody. My name is Eri Saikawa, and it is such an honor to be with very esteemed panelists. And so thank you for having me. One of my projects that you're seeing here is the work on agriculture. We are really interested in how we can have climate smart agriculture that is mitigating climate change, but also air pollution as well. I think we've heard a lot about methane and carbon dioxide, but agriculture is a source of all the greenhouse gases, carbon dioxide, methane, nitrous oxide, and also an air pollutant, ammonia. So what you're seeing here is what kind of agricultural practices can make that happen. Is it possible to have all the greenhouse gases and air pollutant emissions lowered in this mechanism? Usually, as you see at the bottom right, soils serve as a sink for methane. But what we found by taking measurements like that in the field with the chambers, when we had biochar and when we had high carbon to nitrogen ratio, we actually had a very huge peak of methane. So what I would like to say is sometimes we think of a solution as one thing, but that can lead to another problem as well. So if we don't have enough measurements, I think it's very difficult to say what is the real solution. And we want to think about the solution not just for climate change, but also for air pollution, because that's important for food security, for human health. And I think GOSAT has a really big potential because we can look at multi-pollutant and we can look at what would be the impact coming out of that, because we cannot do this measurement everywhere. So I'm very excited and thank you for having me.
Okay, so I am Tazu Saeki from Satellite Observation Center, National Institute for Environmental Studies. So I am a member of NIS GOSAT project. So I'd like to introduce you more practical information on how to get the GOSAT data. So as Hiroshi already talked, NIS has operated 2 satellites, GOSAT and GOSAT-2, with Ministry of Environment of Japan and JAXA. And from these satellite data, NIS has produced data products like CO2 and CH4 concentrations as XCO2 and XCH4, surface flux CO2 and CH4, etc. So the products are free to download from NIS website showing in the slide, free with registration. We need your email address as user ID, but that's all. You can freely download from our website of GOSAT data. So now GOSAT data from 2009 is available on our NIS site. Please see the QR code. And the GOSAT-2 2018 is also from our NIS site is available. So currently we are developing a processing system and a data providing system for GOSAT GW-3 sensor. So this will also be available soon after launch, but the data delivery is a little bit late, but you can freely download our website for GOSAT GW-3 website. So we will soon let you know how to access the GOSAT GW. I think so. So for more information about the GOSAT series, please visit our United Nations exhibition booth number 27. Thank you very much.
Thank you. Is it on? Yes. Thank you. Thank you very much for all the nice talks and for all the nice ideas. I can find specific ideas, specific requests, and that's really great for us to have. Well, time is really short. It's already running out. Can you believe? I can't believe. Yeah, sorry. Yeah, good. Yes. But I think we could have a few minutes for questions and discussions of any other ideas from the floor. Don't forget, we should take a picture. So picture is important these days. So yes, go ahead.
So fantastic panel. Thank you very much. It was really inspiring to listen to you. And I like to introduce myself. I'm Gianpaolo Balsamo. So I'm the director of the Global Greenhouse Gas Watch from the World Meteorological Organization. Yes. So I'd like to ask a question to the panel. So that there is great initiative from the private sector, from the public initiative. We saw UNEP. So my question is, what is the plans for the long-term preservation of this data? Because we need climate data record to be able to inform the Paris Agreement, to be able to see progress across the years and see the emissions really abated and see progress. Methane is fantastic because in 10 years time, because of its life in the atmosphere, we could really see progress in the concentration going down, not only the emissions. So I was wondering what is the plan for the long-term conservation, and please consider WMO as a supporting organization. We really want to help each one of you to succeed and to have a greater use of this data, enlarge the place of using this data. Thank you very much.
Yeah, thank you. Any thoughts?
Well, from a private company point of view, I can tell you that we have contributed all of our data to the UN Environmental Program and to IMEO. So IMEO to me is the natural repository of the historical record of data. Of course, there's licensing restrictions to how that data is used because we have to be a commercial company. But from our point of view, that's where it makes most sense.
Agree. We all agree.
No, maybe two words. Thank you very much, Gianpaolo. And I really echo what you just said. It's a need to get sustainable systems regarding in situ data, in situ network, of course, but also Earth observation and services, modeling system. And this is something I think that is really in line also with European policy. I have to say that those Copernicus services that are implemented by the European Union are really thought in that perspective to develop a long-term strategy and to be able once again to assess the efficiency of our mitigation strategy. Without sustainable system, it will be impossible to objectively assess the efficiency of the policy strategies.
So I just quickly add that I work with the community of GOSAT and OCO2 and other satellite sensors things. So one of the important thing also people do in our community is that so the data is, for example, NIS GOSAT 1, it's from operating from September 2009. And then now it's going on now. Same thing for OCO2, started from 2014. So these people also do the data update because the retrieval schemes for this are very new. They're learning every year new things. The way you apply a priori, the way you do the retrievals, the way you correct for the elevation of the surface, the way you do the albedo. So these things are sometimes reprocessed for the whole period to have a consistency. And the same retrieval scheme is applied like you do in real analysis field. So these things are being ensured and then they are kept, like as Taju said, all re-archived in the website. You can download by version with updates. So thank you for the important point that this thing being carried out. And I mean, it should be more rigorous in this. Thank you very much.
Thank you. Thank you. It's really yes, it's really a great point. And G3W is really one thing we're eager to contribute. Oh, thank you. We talk more later. Okay, thank you. And I think it's time to conclude. It's a really great session. And I would like to thank, on behalf of all the organizers, Minister of the Environment, NIS, and JAMSTEC, thanks for coming and thanks for speaking up and thanks for the future. We look forward to the future collaborations. Thank you very much.